student told me that somebody said that there's going to be an equation sheet. No equation sheet. Okay, I'm not sure where that came from. I do know where it came from. For the lab midterm, you have an equation sheet. Right, y'all have an equation sheet in the lab? Yeah? Did you? Oh, they were in the exam. Okay. Well, anyway, for this exam, are you going to have an equation sheet? No. But look, there's not that many equations, really. There's like 3 equations. So I'm going to write those down just for your reference, just so you have them all available to you. First, there's the projectile motion equations. You know, those are really just variants of our kinematics equations. Y equals V naught YT plus 1/2 AYT squared, and then V naught Y, or excuse me, VY equals V naught Y plus AYT. And then we also have X equals VX times T. And recognize that this one is really the same as this one. It's just AX is equal to 0. So that we have those. Then we have F equals MA. We have our frictional force is mu times Fn. That's really it, unless you want to think about the trig stuff as equations, which you might. And so I could throw in a couple of additional ones, that the x component of a vector is a cosine theta. The y component of a vector is a sine theta. And the magnitude of r is the square root of rx squared plus ry squared. This is all just our vector math from chapter 2 or whatever we did this. And then also the angle theta for r is the inverse tan of ry over rx. Okay, so those are the only equations. I don't really think of these as equations. These are just sort of your trig stuff. So if you know your right angle trigonometry, you're okay. These 3 equations are really just 2 equations just for special cases, and then F equals ma and the frictional force. So those are the equations that you'll have, or you won't have them, but you will know them. And I recommend just to keep them in front of your mind, that when you get your test, you write them on the front of the form. That way you have that in front of you the entire test. I understand that some students have used cheat sheets on some of their exams. I just want to remind you that that is not allowed, that you will get a 0 on the exam if I find you using a cheat sheet, like a piece of paper tucked inside your calculator or wherever. That's not allowed. In fact, that is violating your integrity. And honestly, you're not really gaining that much by doing that. So I know that that's not y'all, okay? But don't do that, because your integrity is worth a lot more than a few points on an exam. I'm not even sure really it would help you that much. Okay? All right. The other thing that somebody asked, they wanted to do an inclined plane problem. This is going to be question number 2, which is actually a set of 4 questions. Now let me tell you, I want to be very clear about what these questions are. You're going to have 4 parts. The first 2 parts are going to be without friction, and then the second 2 parts will be with friction. They'll either be static or dynamic, and so I'll do both. All right, so let's first imagine no friction. What I'll give you is I'll give you an object on an inclined plane. Let's say this angle is, I don't know, let's just say it's 30 degrees. It'll probably be 30 or 60, right? Those are the angles that I use. So we say there's no friction. Let's say that the mass is 3 kilograms, and I want to know a number of things. And I could ask you little questions along the way. Like, for example, I could ask you, what is the normal force? I could ask you, what is the acceleration? I could ask you, what is the x component of the weight, or the y component of the weight? I could ask you a variety of things along the way. First, we draw our coordinate system, like that. It's rotated. Then we draw our forces. I have my force weight. I have my normal force. And since I don't have friction in this first part, that's it. Then I draw my free body diagram. I recommend that you do this. That could be a question, by the way. I could ask you, draw the free body diagram. But even if it's not, I recommend that you do it. It just helps you to orient yourself and to think about the problem and what the answer is, or how to solve the problem. There's Fn. I'm going to go ahead and do step number 2, and that's where I resolve the vectors. Now remember, the angle for this vector right here is 90 minus this angle. So that's going to be 60 degrees. To find the x and y components, Fw cosine of 60, and then Fw sine of 60. So if I wanted to know the normal force for this problem, then I would say the sum of the forces in the y direction, this is step number 3, applying Newton's second law. Sum of the forces in the y direction is Fn minus Fw sine of 60. And on an inclined plane, the forces in the y direction always add up to 0 because it's not accelerating off of the inclined plane. So Fn is equal to Fw sine 60. So that's equal, Fw is 30 newtons. 3 times 10, which is 30. That's 26. Okay, I could ask you other things. Like I would likely ask you, what is the acceleration? And so the acceleration is going to be in the x direction. For example, I know that this object is accelerating down the inclined plane. It's certainly not accelerating up the inclined plane, right? There's no force to pull it up the inclined plane. So if I wanted to know the acceleration, I'd say sum of the forces in the x direction. Look, there's only one force acting in the x direction, and that would be Fw cosine of 60. And that's equal to max. And ax is what I'm looking for. So then I would say Fw cosine 60, that's 30. Cosine 60 equals 3 times ax. Ax equals 5. Actually, messed up a little bit here because it should be negative Fw cosine 60 because it's in the negative x direction, negative 30, and so ax would be negative 5 meters per second squared.
Why did you say that the first one that we did, y was equal to 0? Because the acceleration was 0?
Yeah, because in the y direction, the acceleration is always 0 on the inclined plane. Because this block is not accelerating in this direction, nor is it accelerating in that direction. It might be accelerating in this direction, and in this first part it is. Okay, so that would be the acceleration is minus 5 meters per second squared. Said I could ask other things. I could even throw other forces in there. Like I could say, oh, what if you have a force acting down in this direction, like just a rope or something pulling the block? And that wouldn't change it that much. You would just add in another force there. Say a force F. And then you would have a force F here, and I would tell you what that force is. So it would change the numbers, but it wouldn't really change the way that you work the problem. 3 steps. Draw the free body diagram, resolve the vectors, apply Newton's second law. And when you apply Newton's second law, you're creating equations where that F equals ma, the sum of the forces equals mass times acceleration, so that you can figure out whatever it is you're looking for. Now you will have friction too. You have 2 parts that'll be friction, 2 separate problems, and it'll be the same situation. Get rid of this F right here. Okay. It'll be the same situation except there will be friction. So say, for example, I tell you for those second 2 parts that mu, let's do kinetic friction, that mu k is 0.1. And then I would ask you, what is the acceleration? Your problem's going to look so much like this tomorrow. I don't want it to be a surprise. I want everybody to get it exactly right. Okay? How many of you are going to get it perfectly right? All right. 2 of you, 3 of you. That's great. There's no reason why you shouldn't. We've done these examples a lot in class, and you really should It should be, those first 8 questions should be gimme questions. Right? They should be gimme questions. I want them to be. I really do. So mu k is equal to 0.1. What is the acceleration? First of all, I have to add in the frictional force. The frictional force always opposes the direction of motion. So my frictional force is going to be in this direction, Fk. You might have it so that the block is not traveling down the inclined plane, but it's traveling up the inclined plane. If that were the case, the force would be the opposite direction. You follow what I'm saying? Like I could envision a scenario where the block's not going down, but you have another force that's pulling it up, and then the frictional force would be down the inclined plane. So the frictional force isn't always up the inclined plane, but it's always opposing the direction of motion. For this one, it's up, because this thing is moving down the inclined plane. So I have this Fk. I can add that Fk over here. And if I want to know the acceleration, then I would say the sum of the forces in the x direction equals max. That's Fk minus Fw cosine 60, just like we did before. You just have an extra force in there. Equals max. Oh, but I don't know Fk. And so likely this would be another problem. What is the frictional force? But fortunately, in those first couple problems, I will ask you what is the normal force. That is one of the questions. So I can figure out what Fk is pretty easily by taking this value. I just say Fk equals 0.1 times 26. See how easy that is? So that tells me now what Fk is. That Fk is equal to 2.6 minus this Fw is 30, cosine of 60 equals max. And so that is 2.6 minus 15 equals 3ax. Oh, what's that? Divided by 3, 2.6, 15. 4.1 negative 4.1 meters per second squared is equal to ax. So that would be the answer there. And notice that there are a couple questions embedded here. There's what is Fk, what is the normal force, and now what is the acceleration. So as you're working through the problems, those will be multiple questions that you're answering. If you look at the multiple choice, you'll see this. I'll have problems where consider the figure in the previous problem. What is the blah, blah, blah. It'll be like those, except you'll be able to get half credit for them if you get the answer wrong, but you show correct work. Okay? You ready to get that problem? That's problem number 2. It has 4 parts. It'll count 4 separate questions. You want to do problem number 1 too? Then tomorrow, all you have to do is just sort of like repeat what we're doing here. Right? So problem number 1, and then we'll get to your particular questions, because it's not all just the free response, right? There are other problems on the test. Problem number 1 is going to look at this, a situation like this. I'm going to give you an angle. Let's say it's 30 degrees. I'll give you a speed. Let's say it's 20 meters per second is my initial speed, and I'll ask you any number of things. I'll ask you what is the time, what is the max height, what is the x range. I might ask you what is the velocity or coordinates of the object at a particular time. So the velocity are xy coordinates at certain times. I'll show you how to do that, though we've done that before. It's just, they're parametric equations, right? So if you want to know v, x, or y at a particular time, you just plug in that time. But the very first step on this problem tomorrow, problem number 1, is what is the time? You're going to have to find the time. I'll either ask what is the time at the top of the trajectory, or what is the time, the total time, or something along those lines. But regardless, so your very first step is to find the time. And in order to find the time, we realize that Vy at the top is equal to 0. By the way, there will be some conceptual questions about projectile motion as well, where you have to remember that what happens to Vx that Vx remains constant throughout the entire trajectory because Ax equals 0, and Vy starts out big, gets smaller, goes to 0, gets smaller in the negative direction, and then gets big in the negative direction. So you need to remember those. We'll come back to that afterwards, but just make sure that you're aware of how that works. Okay, so when I say that Vy is equal to 0 at the top, and I say Vy, I look on my form and I have all my equations written there. Vy is equal to V naught y t plus, or excuse me, I'm sorry, not V naught y t, just V naught y plus ay t. V naught y is V naught sine of theta minus 10t, that's equal to 0. So 0 is equal to 20 sine of 30 minus 10t. So t is equal to 1 second. That means at the top of the trajectory, t is equal to 1 second. The time that you use is important. Remember, we've done this in class a bunch of times. If I want to know the max height, I use t equal 1 second. If I want to know the max range, I use t equal 2 seconds. I just double it because that's the time at that particular point. So several things I could ask. I could say, what is y max? I would say v naught yt plus 1/2 ayt squared. That's going to be v naught sine 30, 20 sine 30, times 1 second, because that's the position at y max, or the time at y max, minus 5, that's half a negative 10, times 1 squared. So that's 10 minus 5, that's 5 meters. If I want to know x max, I would say Vx times t. But I'm not using t equal 1 second here. I'm using t total. I'll put TOT for total. And so this is going to be V naught cosine of 30 times 2 seconds. So that's equal to 20 cosine 30. I get 35. Okay, so I'll ask you one or both of those questions. The other thing that I'll likely ask you is what is the velocity or the xy position at a certain time? Okay, I'll just give you a time. So like for example, I might say at t equal 1.2 seconds, what is x, what is y, what is v? The x and y you would just plug in. Like I would say y is equal to this equation at t equal 1.2. Follow what I'm saying there? Can I leave it at that? You want me to write it down? Yeah, okay. So I would say at t equal 1.2, I would say y is equal to v naught y. It's 20 sine 30 times 1.2 minus 5 times 1.2 squared. And that would be the y position. And then the x position would be 20 cosine of 30 times 1.2. X is equal to Vx times t. Those are my two kinematics equations for x and y. And then those would be my x and y coordinates, whatever those are. Another question that I could ask you is what is the velocity at, say, t equal 1.2 seconds? And that's a little bit more complicated, but a good question nonetheless. What is v at t equal 1.2? If you look back at the old test, you'll see some questions like this. It has two components. It has an x component, which is just 20 cosine of 30. So 17. And then it has a y component, which is equal to v naught y plus ayt, which is 20 sine 30, minus 10 times 1.2. That's 10 minus 12, negative 2. Okay, I know this is all really fast, so I just want to make sure we have all these different options, because it could be any one of these. From here, those are the x and y components of the velocity. To find the actual velocity, the magnitude of the velocity, you would say the square root of 17 squared plus negative 2 squared to find the magnitude of that vector. I get 17.1. It'll be 17 rounding, but okay. You're gonna have to do vectors too. There'll be a question about vectors, so we'll do on this in a second. I know that seems like a lot, okay, but you can do it. Like, you know exactly what it's gonna be. So with some practice, you can do it. There's lots of old test questions you can practice on. They're very, very similar to those. Not the same numbers, of course, and not exactly the same, but very, very similar. You know how to do those, to be able to do those 8 questions. That's good news, right? That's good for y'all. And like I said, you get partial credit. So if you're close to getting it right, then you'll get half credit for it. You should do it right. So you benefit from this whole thing. Okay? So the test is 20 questions with 8 free responses at the beginning. It's about weighted equally half and half between the chapters 3 and 4. We're looking at vectors. Those are often on the chapter 1 test, and there will be 3 questions. One of them will be numerical. I'll give you 2 vectors, one axis, one on the axis, one off the axis, and then I'll ask you either the magnitude or the direction of the resultant vector. Every test I've given has one of those questions. It'll be just like those. One on, one off axis, and then I ask you for the resultant. There'll be another one where it's a graphical analysis of vectors, where I show you 2 vectors and I say, hey, what's A plus B, what's A minus B, what's B minus A, and you have to do, we can look at a problem, like you have to figure out what is the resultant vector just by drawing the vectors. And then there will be another that is a just a conceptual. Hey, where is this vector? What quadrant does this vector lie in? Those sorts of questions. I think there is also an X or Y component question, where I give you either the vector and or the angle and or the X or Y component and ask for something that's missing. Okay? Like, for example, listen closely. You listening? I could give you the Y component of a vector and give you the angle of that vector and then ask you for the X component of the vector. Easy? Y'all understand?
It's all trig.
It's just trig, right? It's just trig. That's a little bit differently done. Give you the Y, or what did I say? Give you the Y component of the vector, give you the angle of the vector, and ask you for the X component of the vector. There are a couple ways you can go about that. The tan function is probably the easiest way to go about it, but there you can work around and figure out the magnitude of the vector. You see that? That's a wink. Okay? Let's look at some old tests. Let's see, these are exams too. Oh, it's not working. Let me close this. Oh no, I had this trouble last time. That's okay. I'll pull up the exams on the website and we'll just work them on the side. Are there any exam 1 problems? Do you want to work through, say, a vector problem, for example? Yes, no? Yes, no? No, y'all good on vectors? You want to jump to some of the harder stuff? All right, let's look at, let me read my email. I'm thinking about shaving my beard. What do y'all think? Would that be too weird? Would that be weird? Like, it's either going to happen soon or over the Christmas break. Over the Christmas break, is that better? Okay. Huh?
You gotta see the Friday.
Those are blasted exams. Okay. Let's look at, I don't know, fall 2017. So here, projectile motion stuff. That's going to be like what we'll have on the test. There'll be some conceptual questions about projectile motion. You know, the height of the projectile gives the time. So if it goes higher in the air, that means it was in the air for a longer time. You're going to have a question like this where I give you some statements about projectile motion, and you have to know if they're true or not. Y'all seen questions like that? It will be a collection of statements, and then you have to pick out the ones that are true or not true. Which ones of these are true? Because I know that y'all like those better than just these, right? You understand the difference what I'm saying? You like those better where I have 1, 2, 3, 4, and you have to pick, 1 and 3 are correct?
No.
Yeah, I know you do. Like, I know you're just saying that, but deep down that you do like them. You'll have a problem like this where it's a horizontal problem, projectile motion problem. You want to work that? Okay. Yeah, you will have that. It's a little bit easier than the others. You hit a ball horizontally. Can you read that? I can zoom in. You hit a ball horizontally from a cliff that's 20 meters tall. Picture always helps me. I don't know about y'all, but it always helps me. This distance is 20 meters. That means that y is equal to negative 20. If you don't recognize that right at the beginning, it'll come up because you'll be taking the square root of a negative number, and you're like, oh, what's wrong? The ball has an initial velocity of 5 meters per second, and I want to know what is the horizontal range. What is x equal to? I know that x is equal to vx times t, right? So in order to find this, I first need to know vx. But hey, I already know vx. It's just 5. So now I need to find t. But remember that the time is given by the y motion. And so I can say y is equal to v naught y t plus 1/2 ay t squared. And fortunately for us, this is 0 because all of the velocity is in the x direction. There is no y component to the velocity. So say negative 20 equals 1/2 of negative 10 t squared. That t is equal to 20 divided by 5, which is 4. Square root of that is 2 seconds. And then the x range is vx times t, which is, what's vx? 5 meters per second, 2 seconds, so 10 meters. So there will be a problem like that for projectile motion. I think there is a plotting question where I ask, I don't remember, but make sure you review those. Your y versus t, v and y versus t. You could see a problem like this where I give you the time, okay? And remember with these are a little bit easier because the time is given. So you would say here that I have this object. This is just like in lab with the projectile motion lab where you had to use the quadratic equation. But in this case, you don't have to use the quadratic equation because it tells me the time. It tells me that over here, t is equal to 1.5 seconds. So if I want to know the height of the table, that's y. I just say y is equal to v naught yt, 1/2 ayt squared. That's going to be 20 sine of 30. times 1.5 minus 5, 1.5 squared. We get 3.75 or 4 meters. So D is the right answer there. Okay, so you'll see other projectile motion and force problems along the way, but they'll be simpler one-step problems, 1 or 2-step problems. Okay. Oh, how do I get rid of that? Sorry, folks. Oh, that's not what I want. Okay. You'll see some conceptual questions about Newton's laws and forces. Y'all holler out if there's something that you want to look at here. Going through the concept test would really help with this too, if you just sort of review those questions. You'll have some 1D problems like these. These are all one-dimensional problems, number 19, number 20, number 23. You'll see something like number 24 as well. You want to do some of these? These students are often... Okay, so look, I have a block with mass 2 kilogram, moves on a flat surface. A force causes it to move with an acceleration of 2 meters per second squared. We've had a 10 Newton force acting on a 2 kilogram mass. What's going to be my acceleration? A 10 Newton force acting on a 2 kilogram mass. 5, right. A is F over m. So I'm going to get an acceleration of 5 meters per second squared. But in this case, I have an acceleration of 2 meters per second squared. So that means that something's holding that block back. And the something is a frictional force. I have a force of 10 newtons. I have some resistive force that's causing this 2 kilogram block to move only with an acceleration of 2 meters per second squared. And I want to know what is mu. I want to know what is the coefficient of kinetic friction. I've drawn my free body diagram. I don't need to resolve vectors. I just apply Newton's second law. I get 10 minus F equals the mass, which is 2 kilograms, times the acceleration, which is 2 meters per second squared. So F is equal to 6 newtons. I'm looking for mu, but I know that F is equal to mu times the normal force. So mu is equal to 6 divided by Fn. But because this is on a horizontal surface, Fn is what? Equal to Fw. So Fw is 20. 6 divided by 20. Was that like 0.3, I think? Or 0.4? Yeah, 0.3. Well, my calculator says it's exactly 0.3. That's not right. What is 6 divided by 20? Huh?
0.3.
Oh yeah, 3 over 10. Okay, yeah. It is 0.3. Oh, my calculator was wrong. Okay. I race. That's cool. Too late, I guess. All right, sorry. All right. You can see a problem like this. We did some like this in class, where I have an object with some forces acting on it. This one has a 1,000 Newton force in this direction, and a 600 Newton force in this direction. And the mass is 200 kilograms. And I ask for the velocity after 10 seconds. So I'm looking to find the velocity, which I know is by my kinematics equation, V equals V naught plus AT. But first I have to find the acceleration. So my net force is 400 newtons. My mass is 200 kilograms. A is equal to F over m. So that's 2 meters per second squared, right? That just comes from F equals ma. A equals F over m. And then I can take this and put it in here, and I get V. It starts at rest, so that's 0, plus 2 times 10, so that's equal to 20. Okay? Very similar to these, the questions. They'll be very similar. To practicing the old test will be a big help for you. May I delete? Oops, not delete. You'll know number 24. We did a couple problems like this in class, where you're looking at the equations. First of all, you can look at these and you can tell some right off without really getting deep into it that are wrong. Like, for example, I know this one can't be right, number 3, because this tells me that the normal force is equal to the weight. But I know that on an inclined plane, the normal force is not equal to the weight. If it was a horizontal surface, it would be. But I know right away that 3 is not right. So I can go ahead and cross that out. And that gets rid of that one and that one. So now I'm just down to 3 choices. Let's see, do I know any of these others? Fn minus Fw sine 60. Why is it not right?
So it should be sine 30.
Right, it should be sine of 30 right there. So that one's not right. That gets rid of 1. Now is this other one right? Minus Fk minus Fw cosine 30. What do y'all think? Is that right? Why is it not right? They're in the same direction. Very good. So that one, man, y'all are awesome. So that one's not right either. Let me show you in case you didn't see that. I have my coordinate system here. I know that Fk is in this direction. And then this is going to be the x component of the weight, which is going to be Fw cosine of 30. But that's not that equation. That equation made correct would be Fw cosine 30 minus Fk equals max. If you're looking for those, you'll see problems with sine, like the plus or minus. You'll see problems with the angle, or you'll see problems just with forces that are on different axes that aren't really related to one another at all, that shouldn't even be there. 98% certain we have a question like this. I always do. I'm pretty sure I'll put one on there. If you come to a question, multiple choice questions are really great because if you don't know how to approach it, you just take a big deep breath and say, okay, which of these answers just don't make any sense? And then often, I know on a number of the questions, you should be able to pick out the answer without really doing any work at all. That you just should be able to say, oh, all of these are ridiculous answers. I'm just going to get rid of them. But it takes, I really prefer that you do that. It takes a deeper understanding of the material to be able to do that. And a good dose of confidence to be able to not work the problem, but then say that you know the answer. I like that. Okay, this is like the problems we did earlier. I want to look at another test. Is this helpful for y'all? What was that, fall 17? Let's look at fall 18. Well, let's just look at the exam one right quick, just to make sure we're on track, what you're expecting. You're going to see one just like 24. It'll be just like 24, but just different numbers. Do it? You want me to do it? Okay. Pretty good idea. So I'll either ask the direction or the magnitude of the resultant, either one. But the process is the same. First thing you do is you find AX, AY, BX, BY. AX is 3 cosine 30. AY is 3 sine 30. bx is -4 and by is 0. Bx is -4 because this is 4 units along the negative x-axis. And by is 0 is because this is on the x-axis. It has no y component at all. It's all on the x-axis. In fact, your vectors will be the same. You have one that's off-axis and one that's on-axis. This is 2.6. This is 1.5, -4, and 0. Now, if a plus b is equal to r, you have to find rx and ry. Rx is ax plus bx. That's 2.6 plus -4. Ry is 1.5 plus 0. Okay, so I can look at this and tell you what the answer is. What's the answer? I don't have to do anything further. It has to be B. It has to be in the second quadrant. In fact, if you had drawn out A and B, you probably could have seen that it was in the second quadrant. Let's just try that out. Like A is 3 units and that at 30 degrees, and then B is 4 units, so a little bit longer, but in that direction. So yeah, you could have seen that it should have been over here if you had just drawn it, and then you could have chosen B. But if you're not sure, or if you're not able to choose, then to find theta, you say the inverse tan of 1.5 over 1.4. If you have a fancy calculator, you can put in the signs for the components, but I don't recommend it because you have to have like a TI 90 or whatever above. Because most of your calculators won't recognize that if you put in one of these components negative, they won't recognize which component it is. Like they might say, one of them might say the x component is negative, and the other might say the y component is negative, depending how you put it in. And then that'll give you the wrong angle, depending on what your calculator decides for you. So I recommend that you just leave all the negatives off and think about where that thing should be. So if I do this, the inverse tan of 1.5 over 1.4, I get 47. Oh, we say that's not the answer, but this is the angle, 47 degrees that I just calculated. But the problem gives this angle, which is 180 minus 47, which is 133. Okay? Some of your calculators will calculate this correctly. Like they will give you 133, but some of them won't. I recommend that you do it this way. All right. This should be easy for you geomatics guys, right? Geomatics folks. Easy, like y'all do trig all the time. That's what you do, right? Okay. Let's go back. Anything else on this? Make sure you're not forgetting about the vectors, because it will be on there. What's that, fall 18? Let's look at exam 2. Projectile motion. This is kind of like what you'll see tomorrow, except you know, not free response. This is that problem where you have to find the speed of the rocket. That's where you have to calculate both Vx and Vy. Vx is V naught cosine theta, and Vy is V naught sine theta plus AYT. And then once you do that, the speed is the square root of Vx squared plus Vy squared. Pretty sure there's a problem like that. Okay, you'll follow that? And actually on this one, this is 0 because it doesn't have a y component. So it makes it a little easier. Okay. I'm just going to scan through here. If y'all have any burning questions, let me know. Questions? Any questions from other tests? Number 20? Oh, this is the one you were asking me about the other day, right? Okay, so this one's a little more complicated, but it's not that much. I mean, it's nothing new, really. I have this block, and I'm going to hold it on the wall, and I have to apply a force that creates a frictional force. And if this force is too small, then the thing will fall, because the frictional force will be too small. So I'm going to draw my free body diagram. I'll have F right here. That's what I want to know. And then I have a normal force that's in this direction. In this direction, I'm going to have the static frictional force. And in this direction, I will have the force weight. And I'm asking, what is F equal to? The first thing that I have to do is figure out what is the static frictional force. By the way, nothing's accelerating here, so it's a static problem. So the sum of all these forces will equal to 0. So I can just, because it's a static problem, I can say, for example, that Fs is equal to Fw, which in this case is 20 newtons. I got 20 newtons. I said 2 times 10, 2 times g is 20. So Fs is equal to 20 newtons. And then I know that Fs is equal to mu times the normal force. So I say 20. Oh, and then I further know that the normal force is equal to the force F. That my normal force is whatever force I'm applying to the wall. So I say 20, that's Fs, is equal to mu times F. Oh, but mu is given, 0.1 times F. F is 20 over 0.1, which is 200. Okay. Erase. My eraser's so small.
So because it's static, that the force is the same.
Yeah, because it's static. Yes. In fact, when they're static, you can always set the positive and negative x or y axes equal to one another. We do that with the normal force, right? That we always say the normal force is whatever the opposing force is, and it's the same here. Okay, there's some similar problems here to what we've done. You'll have an elevator problem. You know how to do those? Let's see, there's one here somewhere. Oh, it's right here. This one's descending at 2 meters per second squared. If it had 0 acceleration, the tension in the rope would just be equal to the weight of the block, which is 5,000 newtons. Because it's descending, the tension in the rope is going to be more or less than 5,000. It's a very important question. It's going to be less, right? Good job. So I can get rid of this one, and this one. So it's either A, B, or C. I could venture a guess and say that it's going to be A, because my acceleration is not that big. I know if it's descending at 10 meters per second squared, it'd be 0. It'd be weightless. So I would venture to say A, but maybe I'm not entirely confident about it, but let's just see. So draw a picture, a block, draw my forces. There's my tension. There's my weight. The acceleration is in this direction. It's -2. The negative is really important. Make sure you get the negative. So I'd say the sum of the forces, Ft minus Fw, equals m times A. That is Ft, which is what I'm looking for, minus the weight, which is 5,000, equals the mass, 500, times the acceleration, which is -2 ft, as you thought, is equal to 4,000 newtons. You'll have one like that. If it's ascending, then the tension in the rope is more than the weight. And so you'll probably be able to pick out at least, get rid of several answers just by saying. Okay? Any other questions?
Is there going to be one of those with 2 tension ropes?
Could be, yeah. No, there's not. No. But there could be, but there's not. Okay? But there are 2, I mean, the inclined plane is 2-dimensional, so that's where that comes from. All right? Anything else? Okay, let me stop this. I haven't taken roll yet, so make sure you see me. Don't leave.